Luminance. It can be divided into two types according to the time of emission of light following exposure to X-ray. If after the exposure of X-ray, if the light is emitted immediately, that is within 10 raised to minus 8 seconds, then it is known as fluorescence. If the light is emitted after 10 raised to minus 8 seconds, it is known as phosphorescence. Therefore, there are two types of luminescence, fluorescence and phosphorescence. Fluorescence within 10 raised to minus 8 seconds, phosphorescence after 10 raised to minus 8 seconds. There are three energy band levels. First is the valence band, second is the forbidden band, and third is the conduction band. Let's draw the diagram. Above is the conduction band region, below is the forbidden band, below it is the valence band. Now, what do you mean by fluorescence? As we can see, three energy band level: above conduction, below forbidden, and below it valence. In the valence band, we can see the electron. What happens if suppose a stimulus is given? This electron directly goes to the conduction band, and from the forbidden band, one electron is emitted immediately to the valence band. This difference is given as a photon or a fluorescent light, and the electron which was in the conduction band, it goes in the place of forbidden band. Therefore, fluorescence band, as we know, it immediately emits light after absorption. This is the mechanism that from the forbidden band, immediately electron is transferred to the valence band, giving out photon or a fluorescent light. Now let us revise once again. X-ray has struck the object, fluorescent object. Electron from the valence band directly moves to the conduction band, skipping the forbidden region, and in the forbidden region the electron immediately goes down to the valence band. This difference is given out as a photon or a fluorescent light. Therefore, there is emission of a fluorescent light because of immediate going from the forbidden band to the valence band. The electron in the conduction band then jumps and replaces the deficient forbidden band. Now let us learn about phosphorescence. Same three energy band level: conduction band, forbidden band, and valence band. Now the electron in the valence band, when the X-ray has struck, it directly again goes into the conduction band, but here from the conduction band it goes and rests in the forbidden band. Now when the second stimulus is given, like in the form of heat or other, then from the forbidden band it again goes into the conduction band and drops to the valence band. This difference is given out in the form of photon or a phosphorescence light. Now you can see that in phosphorescence it takes time to emit light because it goes in conduction band and it goes into forbidden band and it rests there, and when again it is stimulated, it goes up and then forms the photon or a phosphorescent light. Therefore, phosphorescence takes time as compared to fluorescence. Now let us revise again. The X-ray has struck. Electron has moved from the valence band to the conduction band. This electron then drops into the forbidden band and it remains in the forbidden band for a variable amount of time. If again a stimulus is given like heat or again, it moves from forbidden band to conduction band and then to the valence band. Therefore, emission of a phosphorescent light. This is known as phosphorescence. Now, heat or other stimulus is given. If you will remember, this is important principle in thermoluminescence dosimetry, which we will discuss during TLD, this phosphorescence process. Therefore, phosphorescence takes time as compared to fluorescence. Let us once again revise. In fluorescence, electron from the valence band directly moves to the conduction band. Therefore, immediately from the forbidden band, electron moves down. This energy difference is given in the form of a photon or a fluorescent light. Therefore, fluorescence is emitted light immediately. Second, phosphorescence. Valence band electron moves to the conduction band and it falls to the forbidden band and remains there for variable amount of time. If again a stimulus is given like a heat or other stimulus, forbidden band to conduction band and then directly it jumps from the conduction band to valence band, this energy difference given in the form of photon or also known as fluorescent light. Where is this phosphorescence used? It is used in the principle of thermoluminescence dosimetry or TLD, which we'll discuss later. Therefore, phosphorescence emits light after a variable amount of time, whereas fluorescence emits lights immediately. Now, where is this 3 energy band principle again used? It is used to divide 3 types of material: conductor, semiconductor and insulator. Conductor will not have forbidden region. Semiconductor will have forbidden region, but it will be very thin, whereas in the insulator it will be thick or in the order of 10 electron volt. Now what is conductor? At normal temperature, it will always have electrons in the conduction band, therefore it will conduct electricity. Insulator at normal temperature, no electrons in the conduction band because the forbidden region is very thick. Whereas remember, in the semiconductor at absolute zero, all electrons are at the valence band, therefore it will behave as an insulator at absolute zero, but at the normal temperature it will act like a conductor because the electrons will be raised to the conduction band. This conductor, semiconductor and insulator we will discuss further in subsequent lectures.